Welcome to video 3 of our Honors Pre-Algebra Blended course. This video is listed under Lesson 1-2, but it actually references some questions that were on your homework in Lesson 1-1, specifically on page 5, numbers 19 through 24. And you may or may not have chosen to do those problems for your homework. If you did, great. If not, I would like for you, either way, whether you did them or not, to jot down these notes into your interactive math notebook. So find the next blank page and just put at the top, video 3, greatest common factor, or GCF, tower method. Okay? And so you might have learned this in previous years in math by your teachers, and it kind of varies on how teachers teach greatest common factor. I know that when I was first teaching, I would always ask students the question, what number goes into 35 and 14? And a lot of times students will say 1. Well, that's correct. 1 goes into all numbers. 1 is a factor of all numbers. So the actual words goes into, it's not really mathematical speaking. We should use the word factor. So 1 is a factor of 35 and 1 is a factor of 14. But 35 has some other factors. 5 times 7 is 35, so I'm going to list 5 and 7 as factors. And then 35 is also a factor. Another way to think of that is in pairs. So 1 times 35 is 35, and 5 times 7 is 35. So that would mean 14 has 1 and 14 as factors, but then also 2 and 7. So the greatest common factor is the greatest factor that they both have in common, which is 7. So we would say 7 is the greatest common factor of 35 and 14. This is one method to make a list of all the factors and then circle the one that's the greatest. This method is really nice. However, it gets a little bit more difficult when you're dealing with larger numbers. So let's say I wanted you to tell me the greatest common factor of 153 and 702. Well, I don't know. We could definitely make a list of the factors, but when you get into bigger numbers, we need to have some other strategies that might help us out. And so even looking at these two, you might say that the greatest common factor is 1 because 1 is even and 1 is odd. But in fact, you need to know some divisibility rules to see if other numbers are factors. And I know that 1 plus 5 plus 3 is equal to 9, and 7 plus 2 is also equal to 9, which tells me that 9 is a factor of both of these numbers. So I'm going to use what I'm going to call this tower method. It kind of looks like a division symbol, but I'm going to pull out the 9, and then I'm going to find out how many times 9 is a factor of 153. So that's 1. And then we have 63 left over, so that's 7. 17 times 9 is 153. And then 9 into 702 is 7, and then that's 63. And then 72, bring down the 2, that's an 8. Okay, these two numbers right here only have 1 as a common factor. So in this case, the greatest common factor of those two numbers, 153 and 702, is 9. Okay? I'm not expecting you to have 100% mastery of this right now. I'm showing you something new and I want you to put it in your notebook. We'll follow up again and do more of these, but I do want to go beyond what the textbook has in just some simple numbers that you can probably do in your head and transfer it to a little bit more difficult problems. Okay? Let's do another one using this tower method. I'm going to erase what I have here and try another problem like 312 and 208. Okay, So to find the greatest common factor, we have a couple of different methods. In this video, we talked about making a list. That works really well with smaller numbers. And now I'm showing you this tower method. Okay, the tower method has you make what looks like a division symbol there. And then I'm going to pull out just a 2 because I know they both end in an even number. I'm going to pull out a 2. 2 is a factor of 312, and that is 156, I believe. Yes. And 2 into 208 is 104. Okay? 156 and 104 also have a common factor of 2 because they both end in even numbers. So I'm going to make another division symbol on top and bring out another 2. 2 into 156 is 78, and 2 into 104 is 52. Oh, 78 and 52 also end in even numbers, so I'm going to pull out another 2. 2 into 78 is 39, and 2 into 52 is 26. Ooh, 39 and 26 both have a common factor. It is 13. 13 into 39 is 3, and 13 into 26 is 2. So to finish this problem and figure out what the greatest common factor is of 312 and 208, you're going to take all of these factors that you pulled out and you're going to multiply them. So 13 times 2 is 26. 26 times 2 is 52. 52 times 2 is 104. Now, going back to these two, you might have known just by looking at those two numbers that 104 times 3 equals 312, and 104 times 2 is 208, making 104 the greatest common factor. But this tower method allows you to pull out 2 at a time. Even if you don't know what the final answer is going to be, you can pull out smaller numbers and figure out the answer. So here's a problem that I would like to have you do on your own. Go ahead and write down the 280 and 144 and try the tower method to find the greatest common factor. Press pause now, and then when you're finished with the problem, press play to see if you have the same answer as I do. Check your work with my work to see if our answer is the same. If you got 8, that is correct. Notice that I pulled out a 2, I pulled out another 2, and I pulled out a third 2. 35 and 18 do not have any common factors other than 1. And so the greatest common factor is 2 times 2 times 2, which is 8. 8 is a factor of 280. 8 is a factor of 144. In fact, it's the greatest common factor of those two numbers. One of my goals this year is to make sure that you understand that there's always more than one way to solve a problem. As a teacher, I like to show the way that I was taught because it makes sense to me, but most of the time I'll push myself to give you a second or third way of solving the same exact problem because I know that all problems can be approached from a variety of ways. So hopefully today's video on finding the greatest common factor helped, and hopefully you learned a new strategy that you can tuck away and possibly use in the future when trying to find the greatest common factor.